Hello everybody, in this lecture we will be providing an alternative solution using inversion for 1994 IMO problem number 2. We are given a triangle ABC, which I already have it here, such that AB and AC are equal, so this is an isosceles triangle. M is the midpoint of base BC, as a result BM is equal to MC as well. And finally, we are given that point O is on AM such that ABO is 90 degrees, but due to symmetry ACO is also 90 degrees. Finally, we connect O and Q, and then we have 2 points E and F such that those two, E is on AB, F is on AC, such that this line EF contains Q. Then we would like to show that OQ is perpendicular to EF if and only if QE is equal to QF. So let's not worry about the third item and the particular question for the moment. So let's consider the following construction. Once I identified the point O on AM such that ABO and ACO are both 90 degrees, noticing that these two BO is equal to CO, I realized, and noticing also that these angles are 90-degree angles, I realized that AB and AC are tangent to the circle centered at O with radius OB, or which is equal to radius OC. So I'm drawing this circle centered at O that goes through B and C. Next, I did draw the line OQ. You can see this blue line here, and I would like to go ahead and reflect point B across OQ so that I find it symmetrical here. Let's call this point as B prime, and in a similar way I will reflect C across OQ again, and I would find the point C prime, so probably somewhere here. Sorry for that, but yeah, so that point is C prime. Now, finally, it is obvious that our shape, due to the symmetry here, because B is symmetric with respect to OQ, and C prime are also symmetrical with respect to OQ, we have an isosceles trapezoid here. Basically, B prime C prime is an isosceles trapezoid. Let me make note of that. B prime C prime is isosceles trapezoid, and in this trapezoid OQ is perpendicular bisector of both BB prime and CC prime, and obviously here where BB prime is parallel to CC prime. Now, because of this nice feature, and because OQ is a perpendicular bisector, so this is a 90-degree angle, this one is a 90-degree angle, if I extend B prime C and BC prime, they would meet at the same point, and let's call this point as Q prime for now. So all these three lines, BC prime, OQ, and B prime C, they will all concur at the point Q prime, and this is still my point Q here. In the next step, I will draw perpendiculars from point O to BC prime first, and so sorry for that. So I drop a perpendicular, and I would let it touch the line segment AB at the point X. So this is a 90-degree angle here. In a similar way, I will draw a perpendicular to the line CB prime, and I would let it intersect AC, and let me extend AC here at this point here, which I call as Y, and this is also 90-degree angle. So notice that if you consider the triangle BXC prime, and if you consider triangle B prime YC, we have quite a few interesting features. Because O is the center of the circle with diameter with radius OB, dropping an altitude to the chord BC prime, it would bisect. So if I call this point as X prime, I already know that BX prime is equal to X prime C prime. In a similar way, B prime C is a chord. From the center, I drop an altitude to that chord, it will bisect B prime C, so therefore therefore, if I call this point as y prime, b prime y prime is equal to y prime c. Now, consider triangles BXC prime and triangle B prime YC. I claim that these two triangles are in fact congruent, and the reason is very simple. First of all, remember that trapezoid BB prime CC prime is isosceles. As a result, BC prime is equal to B prime C. So because BC prime is equal to B prime C. And secondly, also remember that the way we constructed the point x prime by dropping an altitude from O to x prime, and then the way we also dropped an altitude from O to B prime C and called it y prime. So it is the fact, in fact, that these triangles are constructed in such a way that they are exactly symmetric with respect to OQ. And for example, if you will, you can also consider some additional facts. So, and because the triangles are perfectly symmetric with respect to OQ. So if you convinced yourself that in fact these two triangles are congruent triangles, which they obviously are due to all this nice symmetry of this picture, then in the next step you would observe that because OQ is symmetrical with respect to these two triangles, this would immediately imply that in fact QX is equal to QY. So that's the first result. And secondly, we would conclude that OQ is perpendicular to XY. But one thing I'm still missing is that I don't know if X, Q, Y are collinear or not. So if I draw, in fact, the line XY, it can well go through another point, not necessarily Q. In fact, our next claim would be that I would like to show that XQY is in fact collinear, and if they are collinear, XY goes through the point Q, but I already know XY and OQ are perpendicular. As a result, I would finalize the proof by finishing as saying that X is in fact the point E and Y is in fact the point F. So for now, think of X and Y as phantom points, and we still need to show that, so I need to show that X, Q, Y are collinear. For this, I will resort to inversion with respect to our circle here, our circle omega here, and it is quite simple to observe a couple things. First of all, the inversion will take the point Q to Q prime. And the reason is quite simple, because Q is at the intersection of the diagonals of our isosceles trapezoid. If I draw the other diagonal, because OQ is the perpendicular bisector of this trapezoid, and as a result, using for example some pole-polar relationship, so I can say that Q is at the intersection of BC and B prime C prime, but Q prime is in the intersection of BC prime and B prime C. This would immediately imply that in fact this is correct. So Q and Q prime are inverses with respect to that circle. And also in a similar way, it's not too difficult again to observe that X prime, X and X prime are also inverses of each other. And this one is even simpler because consider the, notice that X is at the point of intersection of the two tangencies to the circle at point B and C prime, and also X prime is on the line BC prime. As a result, we can clearly say that the inverse of X is X prime. In a similar way, the inverse of Y, by the same reasoning, is equal to Y prime. Finally, observe that angle OX prime Q prime is 90 degrees, and as well as Q prime Y prime O is also 90 degrees. So these 4 points are in fact concyclic. So the points Q prime, X prime, O, and Y prime are concyclic points. As a result, the circle will go through. So let me draw a circle. So that circle will go through those 4 points. But what is so nice about that circle is that when you look at it, if I invert that circle, notice that my circle goes through the center of through the center of our circle of inversion. As a result, this circle, so our circle Q prime, X prime, O, Y prime will be inverted to a line segment X, Q, Y. I hope that's clear, because X prime will be mapped to X, Y prime will be mapped to Y, and Q prime is mapped to Q. And I know that a circle going through the center of the circle of inversion will be inverted into a line. In fact, that's my line. So therefore, I can go ahead and draw this line going through the points X, Q, and Y. So those points are in fact collinear, and I can say a few more things actually if you want. The blue circle and the blue line will intersect on this circle here and on the circle of inversion, obviously. But regardless, so we come up with this line here. Now I can draw it like that. I know that that line is perpendicular to the line OQ because of inversion again, and as a result, the line OQ is perpendicular to the line which goes through the points X and Y, and X is on AB, Y is on AC. I can rewrite X as E and rewrite Y as F. Now, final thing is to observe that XQ is in fact equal to QY, but that's obvious because earlier we have shown that triangles XQO and YQO are congruent triangles. They share OQ, they both have 90-degree angles, and finally X to Q, Q to X is equal to Q to Y, and so that proves the result beautifully. So this inversion argument is very appealing as well, and hope to see you in our next video.